Welcome to the educational research section of www.happynumbers.org. Today's video is going to deal with levels or scales of measurement. Levels or scales of measurement. There are different types of scales of measurement. In fact, I think we can define measurement as assigning numbers. Measurement is assigning numbers to phenomenon or behavior according to a set of rules, a specific set of rules. So not all numbers are equal, or not all scales or levels of numbers are equal. By the way, the information contained in this video comes from the Trochim and Donnelly text, the Research Methods Knowledge Base, 3rd edition, Atomic Dog. And here are the ISBN numbers. It's an excellent text. Again, I'm not in the business of selling textbooks or even recommending them, but I'm just letting you know where this information is coming from, and in case you're interested, you certainly are more than welcome to look this up. You can look this up online too. I think the entire text is online. Okay, levels or scales of measurement. And this is a quote, direct quote from them. The level of measurement refers to the relationship among the values that are assigned to attributes for a variable. Now, that is a mouthful. But hopefully this diagram, which I took right from their text, will sort of explain what that means. Here we have a variable. And a variable is, let's say, party affiliation. The variable could have been gender, could have been any kind of variable, but here the variable is party affiliation. Now, I've decided that the attributes of that variable will be Republican, Independent, or Democrat. So those are the attributes of the variable party affiliation. And then the values we assign to these attributes, well, if it's a Republican, we'll put a 1 next to the person's name. If the person we're looking at is an independent, we'll put a 2. If the person we're looking at is a Democrat, we'll put a 3. So we've assigned the values of 1 for Republican, 2 for independent, 3 for Democrat. Now, of course, Democrats are not higher than Republicans. And the numbers 1, 2, and 3 really have no meaning. They're just shortcuts or shortcut names for Republican, Democrat, Independent, and Democrat. So the relationship then between these values is they are equal. They are of equal value. And this particular type of level of measurement is called nominal, but we'll talk about that in a minute. But I just wanted to clear up the variable, which is party affiliation, could be gender, could be type of dog, could be a million things. The attributes of that, if it were gender, well, the attributes would be male and female. And then we could assign a value of 0 for male and 1 for female. And then the numbers are exactly the same. The numbers are just categories or codes. So the level of measurement refers to the relationship among the values, in this case the relationship among the values is they're equal, that are assigned to the attributes of a variable, and the attributes of our variable political affiliation were Republican, Independent, and Democrat. All right, let's take a look then at the different levels of measurement. And again, this comes right from their text. This is taken from pages 95 and 96. There are 4 levels of measurement, and they are hierarchical in nature, the lowest one being nominal, then ordinal, then interval, and then ratio. And this is important if you're going to read educational research critically, and if you're going to actually conduct educational research, because it's important to know what level of measurement the researchers are using. Are they using nominal data, ordinal data, interval data, or ratio data? So we're going to take a look at them. We'll start with the lowest level. And nominal data, attributes are only named, and it is the weakest level. So nominal data generally is qualitative or categorical. It's referred to as categorical data because it puts things in categories. The numerical values used simply name the attribute uniquely, like gender, like political affiliation. The numbers are meaningless. There is no ordering of the cases implied, so you don't Republican, Independent, and Democrat. The order makes no difference there. And nominal data says that something is equal or is not equal to. It belongs in this pigeonhole or it doesn't belong in this pigeonhole. Examples of numbers and nominal data would be numbers on the uniforms in sports. They purely identify the player. License plate numbers, social security numbers, these are types of dogs, these are all nominal data. And there is no statistical analysis that is appropriate. There is no addition or multiplication, subtraction, or division. Generally, these nominal data is reported as frequency counts or percentages. There were 78 in our sample there were 78 Republicans, 64 Independents, and 35 Democrats. Or there was 38% Republicans, 67% so and so on. But that's the only way that data is reported. Again, this nominal data purely puts things in categories. It would make no sense whatsoever to add up all the license plate numbers and then divide by the number of license plate numbers and get a mean license plate number. That would be totally, totally inappropriate. So that's nominal data, the lowest form. The next form is ordinal data. And in ordinal data, the attributes can be ordered. Attributes can be rank ordered from highest to lowest, or lowest to highest. And ordinal data has all the properties of nominal data plus rank ordering. Ordinal data can be qualitative or it can be quantitative data. The interval between numbers in the ordinal system is meaningless. You might finish first in a race and I might finish second. Well, I might finish an hour after you, even though I was second, or I might finish 1/100th of a second after you. So the distance between numbers in the ordinal system is meaningless. There's no appropriate statistical analysis. It talks about equal to or not equal to or greater than or less than. In other words, first, second, third, fourth. First is greater than sixth, let's say, but the distance between them is absolutely meaningless. And that is ordinal data. I think ordinal data you will see percentile ranks, those of you that are teachers. If you get students take a standardized test and they're in the 38th percentile or 67th percentile, that's ordinal data, that's rank ordering. But it's a weak form of data also. The next is interval data, and in interval data the distance between the numbers is meaningful. So the distance between attributes or numbers does have meaning. The interval between values is equal and interpretable. As an example, the distance between 30 to 40 degrees Fahrenheit is the same as the distance between 70 to 80 degrees Fahrenheit. Computing averages with interval data makes sense, so we can do addition and subtraction. But with interval data, there is an arbitrary 0 point, and so no ratios can be formed. So an arbitrary 0 point, temperature has an arbitrary 0 point. Actually, I think there is an absolute 0 for temperature, which is a hypothetical. I think in the Kelvin scale, it's something like 273 degrees below 0 when all molecular motion stops, but of course that cannot be measured because if we have an instrument and it gets that cold, the molecular motion stops and the instrument disintegrates. But anyway, temperature, as we use it in centigrade and Fahrenheit, has an arbitrary 0 point. So we cannot say 80 degrees, or 80 degrees is not twice as hot as 40 degrees. Another example in terms of education, intelligence test scores. There is no such thing as no intelligence. So intelligence test scores are interval data, and there is an arbitrary 0 point. If I have 50, if my IQ is 50 and your IQ is 100, that does not mean that you are twice as smart as I am, because there is an arbitrary 0 point. So we can make no ratio comparisons. We will see this kind of data a great deal, interval data, in social and educational research. And computing averages and means and modes and standard deviations, those are appropriate. Those are appropriate for interval data. And then the last form of data, the highest form, is ratio data. And here there is a meaningful absolute zero. And the thing is the twice as much rule. Because sometimes it could be confusing a little bit between interval and ratio data. But if you can say something is twice as much and that makes sense, then you're dealing with ratio data. If you can say twice as much and it doesn't make any sense, then it's not, it's probably interval. Now, with ratio data, since there is an absolute 0 point, we can do addition, subtraction, multiplication, division, all of the inferential statistics, anything. So let's take weight or height or age. These are all ratio data because there is such a thing as no weight. So we can say that something that weighs 100 pounds is twice as heavy as something that weighs 50 pounds. Or we can say that someone who is 6 feet tall is twice as tall as someone who is 3 feet tall. Or we can say someone who is 30 is twice as old as someone who is 15. So ratio data, the most powerful form of data. In the social sciences, most count variables, things that you can count, are ratio data. Let's suppose you have a clinic and they're looking at the number of clients they had in the last year. Well, there could be such a concept as they had no clients. So there is an absolute 0 point, so that would be ratio, or the number of tantrums that you had last month. There may be no tantrums, so there is an absolute 0 point, so that would be ratio data also. Okay, again, then just to review, nominal data, the lowest form, it just names things. It puts things in categories. Ordinal data, it rank orders things from highest to lowest or lowest to highest, but there is no appropriate statistical data analysis that can be used. Interval data, there is a meaningful distance between numbers. There is an equal distance also. However, there's an arbitrary 0 point. So we can do addition and subtraction, we can compute averages and things like that, but we cannot compute ratios. And then of course the final and highest level is ratio data. There is an absolute 0 point. Try the twice as much rule if you're not quite sure. If you can say such and such is twice as much as such and such and it makes sense, then you're dealing with ratio data. And the reason that these things are important, again, is it's important to know what kind of data researchers are reporting, because then you can see if they are using the appropriate data analysis and statistical measures. Also, if you're going to conduct your own research, you want to consider what kind of data you will be collecting and using, and therefore you'll have a better idea of what your data analysis should look like. Well, so that's it for scales of measurement. Thank you very much, and we'll see you next time.